Hi, everybody. I am going to work on solving the OB math question assignment with you. So I'm going to share my screen and show you how to solve these problems. Okay. So here is the assignment, OB math assignment. And we're going to solve questions 1 through 12 of this assignment. And what I'm going to do is I'm going to put in the chat the way to solve the formula or a formula to use to solve. And then I'm also going to work it. Okay. So for question number 1, the patient is ordered ANSEF for treatment of GBS positive culture. The patient is receiving a bolus of 2 grams in 100 mLs normal saline to be administered over 30 minutes, followed by a maintenance dose of 1 gram every 8 hours. So the first part of this question asks, at what rate should the nurse program the pump for the initial dose? And so what we want to do with this is we're going to do the number of milliliters per hour is equal to the milliliters ordered over the minutes ordered times 60 minutes in an hour. So we're going to do, we have an order for 100 milliliters. And we're going to run it over 30 minutes. So we're going to do 100 over 30 times 60 minutes in an hour. 60 over 1. And this is going to equal 200. 200 milliliters per hour is what we're going to set our pump at, and that's what it's going to run for 30 minutes. So I'm also going to put that in the chat. Okay. The second part of this problem says, how many grams will the patient receive in the first 24 hours of treatment? So some people get a little stumped on this question. They don't have any problems determining that we're going to be giving 3 doses because it says in the first 24 hours of treatment, how many grams will the patient receive? So we're going to say in the first 24 hours of treatment, we know the patient is getting the dose every 8 hours. So 24 hours divided by 8 hours is going to be 3 doses. So we know that the very first dose the patient is getting is a bolus of 2 grams. Is the first dose. Each subsequent dose is going to be 1 gram every 8 hours. So after this first 2 gram bolus, 8 hours later, they're going to get 1 gram. And then 8 hours after that, they're going to get 1 gram. So that's 3 doses. 2 grams plus 1 gram plus 1 gram is 4 grams. So the total number of grams the patient will receive in the first 24 hours of treatment will be 4 grams. Any further treatment in subsequent 24-hour periods would be 3 grams because now we're giving 1 gram per hour. But remember that that first dose was a bolus of 2 grams. So I'm going to put that in the chat. Okay. Whoops, I put the same one in again. That didn't help us at all. And now for some reason it's in capitals. Okay. So 2 grams for 1 dose, 1 gram for the next dose, 1 gram for the next dose, 4 grams total in 24 hours. All right. Moving on to question number 2. A patient with a history of opioid abuse is on methadone with a daily dose of 60 milligrams. The doctor has placed an order for the patient to receive a dose every 4 hours. How many milligrams will the patient receive at each dose? So we do know now that we're going to give a total of 60 milligrams and that the patient is getting their doses every 4 hours. So in 24-hour period, we are giving it every 4 hours. So the patient's going to receive 6 doses. Now we know the total number of doses the patient will receive will give them 60 milligrams total for the day. And we know that that's going to be over 6 doses. So if we divide the total amount by the number of doses, we're going to find that 10 milligrams is how many milligrams that patient will get with each dose. So I'm going to put that in the chat. Okay. Question number 3. For question number 3, an African-American patient has a history of 2 preterm births and is receiving betamethasone to stimulate fetal surfactant production. The provider order reads 12.5 milligrams of betamethasone IM every 24 hours for 2 doses. The betamethasone vial is labeled at 25 milligrams per milliliter with a total volume of 1 milliliter. How many milliliters will the nurse draw up in the syringe for each dose ordered? So for this problem, we are going to use the formula of what we want over what we have times the quantity that it's in. So for this patient, we want 12.5 milligrams. What we have is 25 milligrams, and the quantity it's in is 1 ml. Okay, so if you divide out 12.5 divided by 25, you're going to get 0.5 times 1 times 1 equals 0.5 mLs. And that's your dose. And here's that problem in the chat. Interestingly, I'm not sure the chat shows up on the recording. Number 4, an obese patient who weighs 198 pounds has been diagnosed with a deep vein thrombosis in her left leg and needs to be heparinized. The provider orders a bolus of 80 units per kilogram to be infused now and followed by a maintenance infusion. The solution is labeled as 25,000 units of heparin in 1,000 milliliters of D5W. So for the order, heparin bolus, 80 units per kilogram times 1. First, we need to figure out how many kilograms this patient weighs. And so the patient weighs 198 pounds. So 198 pounds divided by 2.2 is how we're going to find our kilograms. And so this equals 90 kilograms. So the next thing we need to do is then multiply the number of units by the number of kilograms. So it says we're going to do 80 units per kilogram times 90 kilograms. And so this will end up being 7,200 units. Now, the second part of this asks about the maintenance. And I'm going to paste this in the chat, even though I'm not sure you can see the chat. So the second part of this, where it says run a maintenance rate of 1,500 units per hour, what rate should the infusion pump be set at? How many milliliters per hour? And so the way that we're going to figure this is to find X mLs per hour. We want to use our milliliters of solution over units in the bag times the number of units ordered per hour So we know that there is 1,000 milliliters in the bag. Here it says 1,000 milliliters and 25,000 units is in the bag. It's hard for me to write sideways. Okay, we're going to multiply that by the number of units that are ordered, which is 1,500 units. Over 1 hour. So if we multiply the top and we multiply the bottom, and then we divide it, our total is going to be 60 mLs per hour. Okay. Number 5, Sylvia has a history of pyelonephritis. The nurse practitioner prescribes 75 milligrams of nitrofurantoin, PO, it's Macrobid, PO to be taken twice daily or BID as a prophylactic. Sylvia requests the liquid formulation. The suspension label reads 25 milligrams in 5 mLs. The nurse is instructing Sylvia on how to take this medication if she uses a medicine cup labeled for 2 tablespoons or 30 mLs at full capacity with increments of tablespoons and corresponding milliliters. How many tablespoons is needed for each dose and how many milliliters? So we want to do what we want. We're going to then again do what we want over what we have times our quantity. So what we want is 75. What we have is 25. And our quantity is in 5 mLs. Okay, so when we divide this 75 divided by 25, this equals 3. So this is 3 times 5 equals 15 milliliters. Okay. And so the problem tells you that 2 tablespoons is 30 milliliters. So it already gave you a hint. So if we're going to give 15 milliliters, it asks how many tablespoons do we need? All right. If 30 milliliters is 2 tablespoons, then 15 milliliters is 1 tablespoon. Okay. And so the answer is 15 milliliters or 1 tablespoon. Number 6, Nikki comes into the OB office stating that she's nauseous and she's having difficulty keeping food down. The nurse asks her about her nutrient intake and teaches her to eat small, bland meals. Nikki requests something else to help with her nausea. Knowing Nikki's husband is with her, the nurse practitioner orders 25 milligrams of promethazine IM. The nurse obtains the vial of promethazine and checks the expiration date and label. The vial reads 50 milligrams in 5 mLs. How many mLs will the nurse inject in Nikki's hip? So again, what we want over what we have and the quantity that it's in. Want over have times the quantity. So what we want is 25. What we have is 50, and it's in 5 milliliters. So 25 divided by 50. I'm getting ahead of myself. 1 second. All right, 25 is what we want. 50 is what we have. It's 0.5. And we need to multiply this by 5. 0.5 times 5. And then our answer is 2.5. And I don't have that one written out to put in the chat for some reason. That's what I was just looking for, sorry. Number 7. Magnolia is admitted to the hospital with hyperemesis gravidarum. The hospital orders 20 milliequivalents of potassium chloride to be infused over 1 hour for serum potassium of 3.0. The solution is labeled 20 milliequivalents of potassium chloride in 100 milliliters of normal saline. What rate will the nurse set the infusion pump to run? Now, the thing that matters for this is we are going to infuse 20 milliequivalents over an hour, and the bag is given to you as 20 milliequivalents. And so we're going to infuse this whole bag, all right? And so all we need to do is the same problem we did, I think at number 1, we want milliliters ordered over the minutes ordered. Over minutes ordered. Times 60 minutes in an hour. So we have 100 milliliters ordered, and we want to give it over 60 minutes. Times, there's 60 minutes in an hour. Now with this problem, if you want to, you can either multiply it straight across on the top and the bottom and then divide it, or you can cross out same things from top and bottom. So since our 60s are the same, I can take those out and go across and say 100 over 1. All right. Alternatively, you could multiply and get 6,000. If I didn't cross those out, I would get 6,000 over 60. And then when I divide this, I still will get 100. And 100 milliliters per hour is the correct answer. That is going to be the rate for number 7. Number 8. Magnolia has a second order for a 500 ml bolus infusion of lactated ringers in 30 minutes. What rate will the nurse set the infusion to run? So we're going to do the same setup. Milliliters ordered over the number of minutes ordered times 60 minutes in an hour. So for this problem, we have 500 milliliters and we want to infuse it over 30 minutes times 60 minutes in an hour. Now, there's a couple things you can do with this. One thing you can do is you can say we're giving 500 units in 30 minutes, or it's 500 milliliters in 30 minutes, so I need to run it twice as fast. And just know that that must be 1,000. Or you can multiply it straight across. And then we get 30. I'm having a hard time doing it sideways. Sorry, guys. Over 30. $30,000 over 30 if I multiply it straight across and straight across. And then I would divide 30,000 divided by 30 and get 1,000. So that's another thing. The other thing you could do is you could eliminate these two. So you can cross out this 30, make this a 2, because 30, this is twice. 30 times 2 is 60. And then multiply 500 times 2 is 1,000 over 1. Any of those ways are going to get you the same answer. Okay, depending on if you like to do dimensional analysis and you like to cross those things. So in case you can see the chat, I'm going to still keep posting the formulas. Number 9. For number 9, the hospitalist orders D5W 50 mLs with 20 milliequivalents of potassium to infuse at 8 milliequivalents potassium per hour on the IV pump. How many milliliters per hour of solution will the nurse set the IV pump? So for this, we can use the want over have. So it says we would like to give 8 milliequivalents per hour. What we have in our bag is 20. The number of milliliters in our bag is 50. Okay. So now if I divide that out, and I'm going to use my calculator, guys, and say we're going to do 8 divided by 20. And we get 0.4. Okay. Then I'm going to take 0.4 and multiply it by 50. So 0.4 times 50 equals 20. And so this is going to run at 20 milliliters per hour. That's number 9. Number 10. Jennifer delivers precipitously. Hold on. I can't erase and read at the same time. Jennifer, sorry, she didn't deliver precipitously yet. She arrives first at labor and delivery, and she's in active labor, and then she delivers precipitously. And so we don't have an IV in, and so we need to give 10 units of Pitocin IM. Okay, this happens. The vial available in the Pyxis is 40 units per milliliter. How many milliliters will the nurse administer? So we want to give, we're going to use want over have again. We want 10 units. We have 40 units. And our quantity is in 1 milliliter. Okay, so we're going to say 10 divided by 40 is 0.25. If I multiply it by 1, it's still going to be 0.25. So we are going to draw up 0.25 mLs of Pitocin. Number 11. Anna presents to her 28-week antepartum visit with a blood pressure of 145/88. The obstetrician orders lab work to evaluate for preeclampsia. All urine protein, liver function tests, and platelets are all within the normal range, and preeclampsia is ruled out. The nurse instructs Anna to call the office or go to the emergency room if she develops headaches or visual changes. On her 33rd week visit, Anna's blood pressure is 150/88, but she still has no other signs of preeclampsia and her lab work remains normal. Since Anna does not have asthma, the obstetrician orders the antihypertensive drug labetalol, a non-selective beta blocker, to manage Anna's diagnosis of gestational hypertension. The prescription reads 100 milligrams labetalol by mouth 3 times a day, or TID. The available dose is 200 milligram tablets. So we're going to do want over have again. All right. So what we want is 100 milligrams. What we have is 200 milligrams per tablet. So our quantity is 1 tablet. Okay. So 100 divided by 200 is 0.5. So each dose is going to be 0.5 tablets for Anna. Okay, so that's the first part of that answer. How many tablets will Anna take with each dose? She's going to take a half a tablet. Now, she is going to take a half a tablet 3 times a day. That's what her order says. And then the next part of the question says, how many tablets will Anna need until her next appointment a week from now? So we know that Anna wants to take a half a tablet each dose, right? So her dose is 0.5 tablets. Okay. And she is going to take it 3 times a day. So she's going to take 1.5 tablets each day total, right? Now she's going to have an appointment in a week. And so she needs to have enough tablets for that week. And if she's taking 1.5 tablets per day and she needs a week's supply, 1.5 times 7 days is 10.5. So she actually needs 11 tablets because they're not going to probably give her a half, but she's going to need 10.5 tablets for the week, or 11. And then the last one we're going to do is question number 12. So Anna goes back to the doctor a week later. And she is now showing clinical signs of preeclampsia. Not surprising. So she's showing signs of preeclampsia. The urine dipstick shows 2+ protein, and she complains of a headache and she's seeing spots. So she has cerebral changes, visual changes. Her blood pressure is 168/98. The obstetrician admits her to the hospital, and her orders include labetalol, 20 milligrams IV now, and then magnesium sulfate bolus of 6 grams to be infused over 30 minutes. So the labetalol concentration that we have is 5 milligrams per milliliter. How many milliliters will the nurse administer IV? So we're going to use want over have. And what we want is 20 milligrams. Okay, what we have is 5 milligrams. And the quantity is 1 milliliter. So if we take 20 and divide it by 5, we're going to get 4. And 4 is how many milliliters we need to give her labetalol IV. All right. So that's the first part of question 12. The next part says that the magnesium salt, so we're going to give her a magnesium sulfate bolus of 6 grams to be infused over 30 minutes. So the way we're going to do this is we're going to set up our magnesium sulfate this way. For magnesium sulfate, to get figure out how many milliliters per hour we're going to set our pump, we want the milliliters ordered over the number of minutes ordered. Okay, times 60 minutes in an hour. Oops, I wrote 6. Okay. So this is one way to do it. We have a couple ways, and I'm going to show you both. So if we do milliliters ordered over minutes ordered, actually, hold on. Milliliters ordered over minutes ordered, 60 minutes in an hour, 150 milliliters over 30 minutes. Actually, we're going to do it differently because that the bag is 40 grams and 1,000 mLs. So my mistake, I thought that it gave us a specific bag, and it didn't. So instead of using that formula, we're going to use a different one. So we're going to do milliliters. To get X mLs per hour, we're going to do the milliliters of solution over the number of grams in the bag times the number of grams ordered over the number of minutes to give and then we're going to times 60 minutes in an hour. So we have 1,000 milliliter bag in our 1,000 milliliters in our bag, and we have 40 grams. So we're going to do 1,000 is our milliliters of solution. Grams in the bag is 40. Then we're going to do our order. So times the order. Our order is 6 grams. So this is the number of grams that they want us to give over the number of minutes to give it. And this bolus needs to go in over 30 minutes. Okay. And then we're going to do it times 60 minutes in an hour. All right. So if we do 1,000 times 6 grams times 60 minutes in an hour, then this is going to be 30, 60, 0, 0, 0 over 40 times 30 times 1, 1,200. And so now we need to divide this out. So if we do 3, 6, 0, 0, 0, 0 divided by 1, 2, 0, 0. We get 300. And this is 300 milliliters per hour times, or for 30 minutes. So 300 milliliters per hour. Okay, if you didn't want to go all the way across and do all of that and get that huge number multiplying, you can cross out some things. So I could have taken out the 30, and 30 goes into 60 twice, and I could have made this a 2. And if you do the multiplication on that, you'd get the same amount. So 300 milliliters per hour is the rate that we're going to run this bolus. All right. Now there's one more part of this question. An additional order is received. Let me erase part of this. An additional order is received to infuse magnesium sulfate at 2 grams per hour after the bolus. Which infusion rate should the nurse set the pump to deliver 2 grams per hour from the same IV solution? So for the last part of this question, we're going to use that same formula here. Okay. And so we don't need to change it. We're going to use the same formula. Now, we know that our milliliters of solution and grams in the bag is still the same. So our milliliters of solution is 1,000. And the number of grams in the bag was 40 grams. Now, the dose is different. Now, what they want us to give, the grams ordered, is 2 grams. And the minutes to give is hourly, 2 grams over 60 minutes. And then we'll do 60 times 60 over 1. Okay. So if I just multiply straight across, I'm going to do 1,000 times 2 times 60. And this is going to be 12 or 120,000 over 40 times 60 times 1 is 2,400. And then we would divide that. So 120 divided by 2,400. The answer is 50. 50 mLs per hour is going to be the rate that our pump will run in order to give 2 grams per hour. Okay. Now you could, again, cross things out. You could cross out these 2 60s. You also could cross out the 2 and make this 20. Okay, if that helps you at all. And then you're going to do 1,000 divided by 20. And that's still going to give you 50. If that's confusing, don't do that. Okay, but that's another option you can do. All right, so that is the end of question 12. And that is the end of the video that I'm doing for the first half of the math. In case you can see the chat, I am going to put those formulas in. And here's the chat in case you couldn't see it. I'm going to scroll through it slowly. 1A, 1B, number 2, number 3, 4A, 4B, number 5. I didn't have a formula for number 6, number 7, 8, 9, 10, 11, A and B, 12, A and B, and C. And if you still can't see the chat, let me know and I can send these formulas to you. Have a great day.